Session 5.4 again. Two topics today. Topic 1, average function value. In this topic, I still want to show you one more example about this formula, the average function value formula. Topic 2, mean value theorem for integrals. Now, take a review first. Review number 1. Let f be a general function. This function has infinitely many function values on the interval AB. Now, I want to take an average of these infinitely many function values. The formula is the average function value is given by this integral. Review number 2, intermediate value theorem from section 2.6. We read this theorem today in the second topic. Now, take a review about IVT from section 2.6. Suppose function f is continuous on the closed interval AB. Here is a diagram about this function. At the point A, function value is this solid point. At B, function value is this solid point. Now suppose y is equal to L. The graph of this equation is a horizontal line. Graph of an equation is the set of all the points that satisfy that equation. All the points that satisfy this equation is a horizontal line. Now suppose this horizontal line lies between function value at A and function value at B. Yeah, this blue horizontal line is between this solid point and this solid point. Now, conclusion. There were exact at least one point C in the open interval AB. C in the open interval AB, that means that C is greater than A and less than B. C is between A and B. Then there are exact at least one point C between A and B, satisfying function value at C is the number L. In this diagram, there are 3 such as C, where function value is the number L. Essentially, IVT says that a continuous curve cannot jump over a horizontal line that lies between the 2 endpoints of the curve. Okay, now I present topic 1. In this topic, I want to show you one more example about this formula, okay? Consider this function on this interval, where A is some positive number. Now, the question is, compute the average function value of this function on this interval. Now, we need to use the average function value formula. By formula, the average function value is this integral. Now, let me compute this integral. The function in this integral is a product. I expand the product, okay, by distributing x to the two terms, a and x, okay. Then apply the difference formula for integral, I get this equation. Okay, now we have two integrals to compute. I compute them by fundamental theorem. A is a constant. A times x, anti-derivative is this function. X squared anti-derivative is this function. Okay, now plug in the upper limit a in x minus plug in the lower limit 0 in x. Then this symbol means this. Similarly, for this, plug in a in x minus plug in 0 in x, then we get this number. Now, simplify this number, we get the answer is a squared over 6. Yeah, this number is the average function value of this function on this interval. Now, the second topic, mean value theorem for integrals. In section 4.12, we have one mean value theorem. The mean value theorem is for derivatives, not for integrals. Take a review about the mean value theorem in section 4.2. Essentially, the theorem says that if a curve is continuous and smooth, smooth means the curve has no corner, then at least one tangent line is parallel to the line that joins the two endpoints of the curve. In this diagram, the line that joins the two endpoints of the curve is this blue line. The theorem guarantees at least one tangent line is parallel to the blue line. Actually, in this diagram, we have two tangent lines that are parallel to the blue line. This is the mean value theorem for derivative in section 4.2. Now, mean value theorem for integrals in this section 5.4. Mean value theorem for integrals. Suppose function f is continuous on the closed interval AB. Function f continuous on the closed interval AB. Now, conclusion. There are exact at least one point C between A and B such that function value at the point C is equal to the average function value, f bar. This function f has many function values over the interval AB. Now, I take an average on those function values. The average function value clearly is between the maximum function value and the minimum function value. Suppose the average function value is here at this point. Now, through this point, I draw a horizontal line. Because the curve is continuous, by the intermediate value theorem, says that continuous curve cannot jump over horizontal line. So when I draw a horizontal line through f bar, the horizontal line will intersect the curve at least one point. The point is the point C. At the point C, function value is equal to f bar. This is the mean value theorem for integrals. Now, in the flow, now the following is one example about this theorem. In this example, we need to determine a C between A and B such that function value at the point C is equal to the average function value. Okay, example. Find all the points at which the given function equals its average value on the given interval. Now, question A. Question A. We need to determine a point C between 1 and 4. There, this function value is equal to the average function value. Let me compute the average function value of this function over this interval first. By formula, average function value is this integral, where A and B are 1 and 4, respectively. This integral is equal to this integral. Now, by fundamental theorem, we compute this integral by fundamental theorem. 1 over x is anti-derivative is lateral law. Then plug in upper limit 4 and lower limit 1 in x. Okay. Then this number is the average function value over this interval. Now to find a point C between 1 and 4 such that function value at C is equal to f bar, we set the function equal f bar and solve this equation. The right hand side is f bar, left hand side is the function. The solution to this equation is this number, 2.1640. Clearly, this number is between 1 and 4. Now, question B. We need to determine a point C between 0 and pi so that function at C is equal to its average function value. Again, compute average function value first. Average function value f bar is this integral by formula. Now A and B are 0 and pi respectively. This integral is equal to this integral. Now again, compute this integral by fundamental theorem. Antiderivative of psi is negative cosine. Then plug in pi, upper limit in x, plug in 0, the lower limit in x, then we get this number. This number is 1/2 because cosine of pi is -1, cosine of 0 is 1. So average function value of this function over this interval is 1/2. Now, to find a point C between 0 and pi, there function value is 1/2. Set the function equal to f bar 1/2 and solve this equation. Move the number pi over 4 to the right side, then we get this equation. Now to find x, take inverse sine on the both sides. Okay, so x is r sine of pi 2 over pi. R sine is inverse sine. By calculator, r sine of pi 2 over pi is 0.6901. This point clearly is between 0 and pi. Pi is 3.14. So at this point, function value is equal to f bar, average function value.